Hey, third grade. Today, you can probably already see before me, I have lots of items because we are going to be doing another experiment together. You will need your textbook. I'll be following along, following the steps in our textbook, starting on page 87. And at the top of 87, let's read this part together. So open up your books and follow along with me. It says, which kind of matter? Today we're focusing on observing and inferring. So we're going to be observing some different objects and then making some inferences based off of what we experiment. So which kinds of matter? Which kind of matter? Matter is found in different forms. The food you eat, the juice you drink, and the air you breathe are types of matter. The three types of matter. Solid, that would be like food for an example. The juice you drink would be liquid, and the air you breathe would be gas. So solid, liquid, and gas are the three states of matter. But if you list their properties, you will find each type is different. So our experiment today, we're going to be looking at solids, liquids, and gases, and using the table on page 73 to kind of compare them, okay? So keep your book open, because I'll be following along the steps, and I'll probably be kind of running back and forth between our worksheet and between this area for our experiment, so that way we can work on this together. Okay, so the purpose of our experiment today is to compare properties of different kinds of matter, solid, liquid, and gas. So procedure, what are we going to do? Observe our objects. So number one, we're going to measure and record the mass or weight of the first object in the chart in your activity manual. So my objects today that we are going to record their mass, a few of my favorite things, coffee mug and a bag of coffee beans. Here are two objects. When I go behind the screen, I'll write those down. We'll do that together. So let's record the mass of the coffee mug first. Here's my scale. I'm going to put everything on 0 first, and I'll set this in the center, and we will find how much it weighs. I think I'm going to move the 100 gram one first. Ooh, yeah. It's pretty heavy. Okay, so it's not 500 grams. So I'll go back to the 400, and then I'm going to move my 10s in the back. Oh, do you see it start moving? Okay, too heavy. Too light. Move the ones here. Oh, getting closer. Remember, I'm looking for this to 0. A little too heavy still. Oh, it's really close. A little bit. Oops, it bumped it. Getting closer. Oops, I don't want to bump the table. Okay, I think we found it. Perfect. Okay, the total mass of our coffee cup is 433 grams. So I'm going to go behind the screen and let's write that down. So I'm going to have to adjust a little bit here. This is going to be me going back and forth today. So here's our paper. Okay, let's write down our objects. Okay, so our materials, our two objects are the mug and the beans, coffee beans, but we'll just write beans. So mug and the beans. And in our table, we have mass, volume, and shape. So remember, mass is how much it measures on the balance or on the scale. So for object 1, the mug, the mass was 433 grams. And I'll show you, I'll zoom in a little bit on the scale. Okay, the hundreds is that second bar, so see it's pointed at 400. Then we have 33 grams. Okay, pretty cool. All right, I think I'll leave my camera like this. Our second thing is to measure the mass of object 2, which is the beans. Okay, so let's move that back. Remember, on our scale, or on our balance, we'll put everything back at 0, and then let's measure the coffee beans. Peace coffee, it's pretty good. Okay, maybe I'll lay it flat like this. I think that's less likely to tip over. Okay, so I think I'll start by moving the hundreds again. And let's see if we can get our balance to move. Okay, so when it drops low, that means it's too heavy. So I gotta go back. So let's put it on 300. And then I'll move my, what if it weighed the same? I haven't measured these yet, so I don't know. It's a little heavier. Okay, it's not gonna be the same. Okay, too heavy because it dropped low, so I'm on 60, so let's move it to 50. And then it's high, so it's still too light. Let's add some single grams. If I barely flick it, that's going to be the best way. It's moving. Okay. Oh, it's really close. A little bit too heavy. Put it on the 7. I'll let it balance. Nice. Oh, my hair is touching it. Okay. So, I don't know why I'm whispering because I don't want it to move. Okay, so our coffee beans today measure 357 grams. So I'm gonna go behind the screen and let's write that mass down. Here, I'll zoom in so you can see first. Okay, so there's the 300 in the middle, 50 are 10s in the back, and then 7 are 1s. Okay, so 300. So object 2 is the beans. Here, I'll do this. Number 1 is the mug. Number 2 is the beans. So object 2 was 357 grams. Okay, so like I said, you want your book out with you as well because we're going to be following these steps in order, the procedure, right? That's the list of steps in order. So I'm just going to move this over so I can show you and we can read a little bit together. So we measured and recorded the mass of the first object in the chart in our activity manual. And now we're going to observe whether our objects take up space and mark the chart with an X if it does. Okay, so I'm just going to slide this up out of the way. And when we're talking about taking up space, we're talking about the volume of an object. Okay, so if I have my coffee cup, right, is it taking up space currently? Well, yeah, it's an object. What about my coffee beans? Is that taking up space currently? Yeah, it's not like it's invisible. They both are real objects and they both take up space. So let's put an X there. I know that kind of sounds silly, but it's a good observation for us to record. Now we are going to place these objects, okay, moving to number 3, place the object in the container to see if the volume changes to fill the entire container. Mark whether the volume stays the same or changes to fill the entire container. I'll show you what that looks like. So let me slide this up, back. And here's my container today. It's just a clear Tupperware. Clear so that you can see. And now this might also sound kind of silly, but when I take this coffee mug and I put it inside this container, is the volume staying the same or changing to fill the entire container? Is that cup changing or is it staying a cup even if I put it in a container? It's staying the same, okay? Same with, I know it seems silly, it's a good observation. Same with this coffee beans. When I throw it in the container, Is it all of a sudden changing shape? No, it's the same thing. Nothing has changed about this shape. It's just been put into a container. So let's record that onto our worksheet. Back to our table. So stays the same or keeps its volume. Does the cup stay the same even when I put it in a container? Yes. Does the coffee bean stay the same even when I put it in a container? Yes. And I know that sounds silly, but it will make more sense when we get to water, okay? And when we get to air. Okay, next. Step 4. Look to see if the object keeps its shape or takes the shape of the container and mark your observations. Repeat steps 1 through 3 with the second object. We've kind of been doing that at the same time today. So when I look at my container again and I take this coffee mug, I know it's silly, but I put it in this clear container, is the coffee mug staying the same shape? Did this change at all? No. Same with the beans. When I put them in the container, is this still the same shape? Yes, they're still the same shape. So does it change to fill the container or take the volume of the container? No. So we're going to leave those blank for both of those. The beans stay the shape of the beans in the bag. The coffee mug stays the shape of the mug, even when I put it in a container. And like I said, this will make a little bit more sense when we get to water and air. Right now it seems kind of silly, but we have to record the same observations for each of our objects, for our solids, liquid, and gas. Okay, let me go back to our book here. Turn the page with me. And we are going to now observe water. So we just observed solids, okay? And now we're going to do some observations with water. So step 6 says, measure the mass of the empty container, add 200 ml or milliliters of water, and measure the mass again. Record the difference between the two measurements. Remember, difference has to do with subtraction. So let me put this back up. I'll go back to our scale here. I'll put these out of the way so that we can see. Okay, so first step was to measure our container. So let me put this back to 0 and let's measure the mass of the container. Okay. I'm not going to move the 100 grams because this feels pretty light, so I'm going to make an estimate first. Ooh, 50 grams, 60, 70 is too heavy. Okay, so let's go back to our 60, and then I'm going to move the single very carefully. Oh, it's very close. My hair is in the way. I keep whispering. Just letting it balance. It's very, very close. Ooh, okay. So the mass of our container is 61.5 grams. And for the sake of doing some easy subtraction, I'm going to round up and say that it's 62 grams. That's just going to be a little bit easier for us to subtract today since we haven't worked a ton with decimals. So let's record that mass. Okay, I'll zoom in again so that you can see. Scale 61.5, but like I said, we're gonna round to the 2 for some easier subtraction today. And let's go back to our worksheet. Water. So the measure on the balance, so the mass is 62, I said, yeah, 62 grams. Okay. The next step is to add 200 milliliters of water and then measure the mass again, record the difference between the two measurements. So even though I have 62 here now, we'll record the mass, we'll do a subtraction, and then we'll have our final answer here.